Well, thanks for joining our webinar today. I'm Kevin McGruin with GigaSpaces. I'm the SVP for the Americas. With me is Rajiv Shah, who is our Senior Technical Director. And this afternoon, we're going to be going through a session on data virtualization meets digital integration hub. And the agenda for the session is going to cover first some of the challenges that we see being faced around digital acceleration. Next, we'll go into a little bit more detailed overview of the Smart Digital Integration Hub and the architecture, and that will be followed by a live demonstration and finish up with some conclusions and summary. So for those of you not familiar with GigaSpaces, we are a leading provider of in-memory technology. We've been around for about 20 years and have really led the market relative to innovation for how to use in-memory data grids to really drive new innovation, accelerate applications. And we have two product areas, one which is Smart Cache for caching solutions. The other is the Smart Digital Integration Hub, which we'll be focusing more time today. What you find is that we are being utilized, our technologies are being utilized across premier clients that you see listed on this chart, from Bank of America, American Airlines, FIS, Goldman Sachs, Morgan Stanley, Early Warning, many different clients are using us every day for mission critical production applications, and we're very proud of the great success these clients have had with us. And also, as you see in the bottom of the slide, we've actually have won significant number of awards and recognitions in the industry, and we're also recognized by Gartner in terms of what we do, and I'll talk more about that shortly. So digital innovation challenges. Clearly, with the pandemic, we've seen a huge drive towards digital. Everything has gone virtual, everything has gone digital. Many companies recognize that they win or lose market share based upon how strong their digital position is in terms of what they do. You know, Gartner had their Innovation Insight report that was out this past January, and they spoke about how application leaders are struggling to deliver high throughput, responsive, and reliable APIs to service their needs, right? And the challenge there is how these new approaches integrate with back-end systems of record. And clearly, the need to drive more of your digital footprint, more of how you interact with your customers, your consumers, your patients, your students, depending upon which market you're in, is really all focused on your digital position and how quickly you can go out to market in that capacity. So traditionally, what we have seen from the majority of organizations out there when they start to deploy new digital apps, most organizations follow an API point-to-point integration approach. And as the line of business comes to the app dev team and say, okay, we need to have a new application, the business owner isn't thinking about, well, how many different back-end systems of record do you need to integrate to? That's on the development team to do that. So you start looking at, point-to-point integration, and you typically are dealing with, for each system of record on the back end, multiple points of integration. And clearly this becomes a complex approach of what people are dealing with. And what we find is that this is a coupled architecture, number one, so that the digital app is directly coupled to the back-end system of record. Number two, this is also request-based, so that each and every time the digital app requests information, it goes back to the system of record and pulls the information and brings it back, and the join is typically done at the client level. Part of the challenge as well here is that if you need to modernize any of these apps, that can have a direct impact on the digital app. And obviously the performance of the digital app is always reliant on the weakest link on the system of record. So now you complete your first digital application. And then the line of business comes to you and says, okay, we need to do a new digital app, in which case you need to, again, build out the individual integration points from an API perspective to the backend system of record. And then up comes digital application number 3, digital application number 4, digital application number 5. So you're basically doing a rinse and repeat for each of these new initiatives. Some may need access to the same data that was done in the first digital app. Some may need additional data sources to be brought in. And so these all just make your position in terms of how you're operating against the system of record even more of an issue, because now you're even more dependent in this spaghetti code type of approach. And again, this is coupled, this is a request-based approach. And part of what we have seen is that your developers are spending anywhere from 50 to 70% of the time just on the integration to the back-end data, as opposed to really focusing their energies where you really need to, which is on the front-end digital application user experience and business logic, which is actually the most critical for what we're trying to get done here. So one of the things that Gartner came out with in their Innovation Insights report that I referenced earlier is a new emerging architecture that they see happening to help really streamline the process of how you innovate for new digital applications. And the new architecture that they coined the phrase is Digital Integration Hub, DIH. And again, we see the applications on the top layer, we see the data or the systems of record on the bottom. And now what we're introducing is this Digital Integration Hub that enables you to have one unified data model. It enables you to have a high performance data store in the middle and be able to really reduce and minimize the number of APIs that are going against the system from the digital application side and in terms of the integration to the back end. So you're less reliant on the system of record being up and operational because the data is being ingested and uploaded into the DIH on a regular basis to meet the business requirements. So now what you're seeing is a decoupled model, number one. Number two, even of a bigger significance here, is an event-based integration layer so that the data is being pushed from the system of record into the DIH. And the information can be updated as needed based upon the business rules. So you can have a CDC or streaming data that's enabling you to have an always-on environment in the DIH so that the digital apps have a consistent, high availability, high scalable approach, and that if one of the backend systems is not up to par in terms of speed, if it's down for maintenance, if there's some other issue going on, that will not impact the digital application. So that becomes a very significant difference in how you innovate with more agility and speed to really address the digital transactional requirements of your organization. So many organizations have gone down the path of utilizing a data virtualization engine to help them to pull information from disparate data sources in a very seamless way. The majority of these types of applications are fulfilling the need for queries and analytic requirements for business intelligence tools. And in this case, the data virtualization engine doesn't require you to do a physical replication of the data. What you're doing is you're moving the relevant metadata into the data virtualization engine itself. And you'll be able to create base views. You're able to have semantic views of the data to solve and address different business requirements there. But the data itself is still stored at the system of record. So this is facilitating a request-based coupled architecture, which is fine to meet the needs of analytical queries at the end user level. Now, that being said, many times what we have seen is there are different types of backend systems of record that need help. They need to be performing better. They need to accelerate the performance because typically these type of DV engines, what do they do in terms of query optimization? They push the query down to the underlying database and have the query optimization actually happen at that level. Then they return the answer set to the DV engine, where it then serves up the data to the end user. So there are times when a backend data source needs help in terms of acceleration. One of the things that you see in the graphic on the left is one of the data sources on the bottom layer is called Smart Cache. Smart Cache is one of our products that you can utilize so you can essentially ingest data from any system of record that is a slow performer, move that into our Smart Cache engine, and then serve that up into the DV platform to make your performance faster in terms of these type of queries. However, for many organizations that are going down the path of looking at how do we complement the DV environment with an approach that helps us address the high performance needs for new digital transactional services, this is when a digital integration hub really makes a difference. So now you have the DV engine performing the requirements for request-based coupled needs for analytical applications, and you have the digital integration hub providing a very highly robust, high-performing environment where you're moving the key relevant data, the highest priority data into the platform, and so that the data is always on to meet the needs for high-level scalability, availability, speed, consistency to serve up to your digital apps. And in fact, one of the key differentials here is that now this environment enables you to bring in new data sources, new data tables, without bringing down the unified data model so that your existing digital apps are not impacted. You can launch new digital applications rapidly and really spend the time on the front end user experience and business logic versus worrying about the data prep. So this is a significant differential in terms of how you can launch and support your digital strategies for new deployment. So again, DV is being utilized for request-based coupled architecture to meet individual analytical requirements. The digital integration hub approach enables you to serve up data to meet your digital application needs, where you need to have the highest level of speed and availability with the core relevant data stored in the DIH, separating it and decoupling it from the backend systems of record. So the overall benefits now is that your line of business, when they come to the IT team, to the DevOps team, and they're looking for ways to accelerate, be more competitive in how they're delivering new digital apps, now they find that their needs are being met. What you'll find is that your developer teams now are spending way less time on the data prep side. In fact, as I said earlier, 50 to 70% typically is what we have seen of what organizations were spending through a coupled architecture approach. So a DIH means that the data is always on, and you can now build up new digital apps without having to go back to the system of record each and every time. And lastly is that your operations team now has the ability to have a platform that has minimal downtime. It gives them the consistency, the high scale capabilities, the speed that's needed to really address the customer experience that you need to achieve. And it enables your organization to be much more competitive in this new world we live in. So that's a highlight of some of the benefits. Now, so what is it that GigaSpaces provides? We provide a platform called the Smart Digital Integration Hub. And, as I said before, when you're going down the path of building out, different point-to-point integrations through APIs, many organizations find themselves in this maze of spaghetti code, if you will, where you have many, many different apps that are being deployed. You have many points of integration to the backend systems of record, whether it's going after legacy, whether it's going after SQL data sources, non-SQL data sources, cloud databases. This becomes a very complex, difficult environment to maintain, and you don't have consistency in terms of scale or speed in terms of what you're trying to get done. So one of the things that Gartner outlined in their Innovations Insights report is the whole concept of this digital integration hub. And in fact, they referred to GigaSpaces as one of the leading providers of an out-of-the-box solution for a digital integration hub. So the Smart DIH is a completely packaged offering. It provides you the ability to deploy much faster with a pre-integrated solution, and it gives you very high performance through our in-memory data grid. And by the way, the in-memory data grid can be completely distributed, and Rajiv will go into more detail there. And what you'll find is that you have less cooks in the kitchen, less vendors that you need to deal with in terms of how you do it yourself in terms of building out an application, because this is all packaged. And it also includes pluggable database connectors and can be deployed both on-prem, in a hybrid cloud environment, as well as a multi-cloud environment. And ultimately, you'll find that there's less code to write so that your developers are being highly efficient in terms of what they do. And the costs for building, maintaining, and enhancing go way down from that perspective. So next, let me introduce Rajiv to talk more about the actual architecture that we see here. I want to stop sharing for a second and let Rajiv share on his desktop 1 second. Go ahead, Rajiv, all yours. You share?
No, I'm sad. Zoom hung up. It is.
You're going to share my screen?
Sure, I can go through that slide for now.
Okay. Did you stop sharing?
Just hang up.
That's right. Now you need to stop sharing.
No, I know that, but Zoom is hung up. Like sometimes Zoom needs me.
Okay, hang on, guys. We had an issue with Zoom. Let's go back to my screen for a second. Okay, so Rajiv. You may, discuss this then. Let me
Okay.
make it
So
larger.
now I'm going to explain that how is the GigaSpaces DIH architecture work. So what we are trying to demonstrate here is that now how GigaSpaces will help you.
Wait for that to come up. Go ahead. Oh, go ahead.
How GigaSpace will help you to decouple the architecture, and also instead of event-based, how we will help you to do how from request-based, how GigaSpace will help you to do the event-based architecture. And to do so, what we are demonstrating here is that still you have all your application on top, you still have a databases in bottom, but now instead of each of your app communicating to multiple data sources, what GigaSpaces do is that GigaSpaces provide built-in change data capture tool. So it will help you to load the data from any of the data sources. It could be traditional RDBMS, unstructured NoSQL database, files or MQ, mainframe, or any cloud data source. So GigaSpaces provide necessary module. So just writing the few configuration, it will do the initial load from all of these databases. Also using the change data capture tool, GigaSpaces will do event-based data replication. So it means that if any other application modify any of your data sources, that changes will be replicated in GigaSpaces. So it means that any given time, data in your underlying data source and GigaSpaces are in sync. Now, GigaSpaces also allow you to build, deploy the microservices, which is responsible to do any type of validation cleansing. And once you are done with that, you are going to register your data to GigaSpaces distributed database. So another benefit here is that now instead of monolithic database, now you are going to store your data in distributed data grid, which is scaled vertically and horizontally. So when your microservices is going to access your data, it will be extremely low latency. Also in parallel to that, when it will make a query, it will send a query to appropriate processes. So that will allow you high level of concurrency, which is normally not available in traditional data sources. Now, GigaSpaces also allow you to store data in a different tier, such as volatile memory, which is a RAM, but also in parallel to that, we support storing the data in non-volatile memory, such as SAN/NAS or cloud EFS or SSD or HDD. So it means that now based on your business logic, you will decide that how to store a data per table, such as for account. You may want to store your premier accounts in a RAM, whereas non-premium account in a low-cost storage. So now you are reducing total cost of ownership drastically without compromising with the performance for your high network people. Also in parallel to that, GigaSpaces allow unified data model. What it means is that when you have a data available in different type of data source, which could be structured, semi-structured, or unstructured. So as you are going to load the data, it is going to create the unified model and store it in a GigaSpaces. So that way, when your client apps make a call, it doesn't need to do the real-time aggregation. And now to do so, I'll demonstrate how exactly it can be done in a real demo. And just to demonstrate one more thing, which is the right side of our architecture, is that GigaSpaces is being deployed on an on-premise, hybrid, multi-cloud, and also we have a native support to any of those Kubernetes. And in parallel to that, GigaSpaces provide necessary tools to replicate the data between any of these environments. Here is the architecture I'm going to showcase for the demo. And what we are trying to do is that step one, so first of all, what is this demo? We are showcasing that, hey, you have a customer 360 use case where you are storing your data in different data sources, such as your account data is stored in a MySQL, your customer data is stored in a MongoDB, and also as a part of your report, you want to demonstrate the aggregated account. It means that that particular object is a combination or aggregation of account and customer table. Then we will demonstrate that how to load the data from SQL Server But also in parallel to that, as previously Kevin explained that GigaSpaces provide event-based architecture. So here as a part of demo, I'll showcase that, hey, if someone is modifying any data in a SQL server with matter of sub-second, or I wouldn't say sub-second because sub-second we use when you have a millions of data, but here we are going to modify only single row. So it should be in a nanosecond. You will see the data from SQL server been replicated to GigaSpaces. And now give us one moment so I can share my screen and showcase you how exactly it works. Okay, so what I have done is that as we have a limited time, the only step I have done is that just initialize the server and just deploy the GigaSpaces. And to do so, we have done two things. One is that we have created volatile space, which is the demo, which runs only on a RAM, whereas the second one, which is the tier storage, which consists of RAM and also SSD. It is too small. Okay. So here, let me just go. I will just do back and forth between these two screens, so that way you guys can easily connect the dots. So here is the RAM-based area where, or RAM-based case, we are going to load this data. So let me just do one thing. And another thing here, you're gonna see that I'm just going to click one button. So that way you can see that how easy to use the GigaSpaces. And as I click just one button, which is called initialize, what it is going to do is that here you can see only two services. Now it is going to deploy the module to connect to MySQL, MongoDB, and also load the data. So you are seeing right here that it's deploying the module to connect to MySQL, and also it will load the data. And as it's taking time, because this is not a canned demo, this is real demo. And as you know that real work takes time, but you can also see that in matter of seconds, it has deployed two modules. So now, if you go to this demo space, you can see that not only it connected to the MySQL and MongoDB, but also it loaded the data. Here you can see that it loaded 4500 from account table. And now I'm going to demonstrate the real environment for MySQL. So this is the MySQL database. You can see here connection, string, and everything. This is the server. These are the authentication, and this is the database. And here I'm just going to run this query. So you can see that from MySQL database, it's fetching a data. And here from MySQL, it takes good amount of time just to fetch the number of record. And that is one of the reasons customers are using GigaSpaces, because when you want to do the same thing in a GigaSpaces, the results are much, much quicker. Now, as a next step, what I'm going to do is that I deploy the module to connect to Kafka and SQL Server, and also deploy the other services, as we can showcase that GigaSpaces support multiple protocols. So it's regarding that. So as I just click this one button called initialize it, we will start seeing the different services being deployed here. Or in between, I'm just showcasing that we are going to load the data from SQL Server. So here is the SQL Server connection. Here is the loans table, and here is the loan data. And what we will do is that in next few minutes, we will showcase that when we change data here, how quickly it will replicate that data in GigaSpaces. So here, as we just came back, it has deployed the pluggable connector to connect to SQL Server database. It also deployed the Kafka connector. Now it's going to deploy the remaining services. And also in parallel to that, if we come here, you can see that it has loaded this additional table structure. and data. It loaded the file record from SQL Server, and it also created the table structure for account aggregation. And once it will be done, we'll showcase the remaining things. Just wait for a moment. We already have 8 services deployed. And what is this? So in few minutes, I'll also showcase that, hey, GigaSpaces also allow you to create the microservices just using the web-based flow instead of open the IDE and deploy it. So now I'll start streaming the data from Kafka. So I'll start streaming the data from Kafka. If we go here, you will see that data will start coming. So you can see that this is real demo. We are using the Terraform and Ansible to do the necessary and automated deployment using the standard or industry standard CI/CD pipeline. So here you are seeing that it's loaded 100,000 objects from a Kafka. So once we come here, now you can see that you can see those 100,000 data from transaction object, transaction doc object. Also, it has created this aggregated data. So what we are showcasing here is that in a Kafka, it has only, as you guys know, that it's unstructured data. So it has only unstructured transaction doc, but using microservices, not only we loaded the data into here as an unstructured object, but using the microservices, it did the aggregation and do the computation and loaded this transaction data. And same data has been also loaded to persistent storage / our tiered storage. So now you can see that all this data are loaded. So now I showcase how to do the real-time data modification from in SQL Server and replicate to the GigaSpaces. So here you can see that ID is 101 and interest rate is 2.1, right? So if we go here, ID is 101, interest rate is 2.1. Now, yesterday Fed increased the rate by 0.5%. So let's just change this one to 2.6. And as we click here, we are saving here. So now your borrowing cost increased by 0.5%. So when we go to the GigaSpaces and when we will run this query, you can see that this data has been replicated in a GigaSpaces. So what it did is that we modify using the client data in a loans table here. SQL Server wrote that data to the transaction log. Division captured that data, send it to Kafka, and GigaSpaces captured that data from Kafka and updated GigaSpaces in matter of microsecond. Now, what I am going to showcase is that how to create the microservices with a few clicks. So here is the interface for that. To see the data, and then I open the interface to how to create. So what you're going to do, click the new here. So it will create the microservices here. And to do so, we are going to create the microservices with REST endpoint called get@txn. It is going to run on protocol 8116 on TCP IP. What is going to do? The responsibility is a transaction service. And also we will specify the query associated with it. Now, when we'll click this, what it will do is that it will generate the code, attach the necessary Maven dependency, create the jar file, and then deploy it to GigaSpaces. So normally, if you want to do that, it's a few hour to few day process, but it's here, it will do in a less than minute or so. So right now, it's creating the Maven module. Once it is done, it is going to deploy. And once it's going to deploy, I'll showcase from here that how to generate web-based report using the REST endpoint we just deployed. So if we go here, So if you observe that what we did is that literally 4 steps to build this end-to-end multi-data source application. Step 1, we created the EC2 instance. Step 2, we just deployed our DIH platform, deployed necessary database, loaded the data over there. During the initial load, we loaded the data from multiple data sources to GigaSpaces. When we click live connector, it started the connection to Kafka streaming and load the data. When we did the second streaming, it did the aggregation, and we have seen those data here. So now if you see here, it already deployed the get TXN microservices. And now before we do so, let's just go here, verify that we have all necessary data. So we see all transaction doc here. So when we go here, we know that there is one of the account called 192. So when we hit this one, what it's doing is that it's making call to your REST endpoint. That REST endpoint is going to database, fetching the data from account table, transaction table, making the real-time join in memory and returning the data. Now I'll just showcase one more account. Here it has only 2 records. So you can see here that how easy to load the data from multiple data source, do the real-time SQL join in memory, also fetching the data from different type of volatile and non-volatile data sources and demonstrate the result over there. And I think I'll just stop it here. But if you guys have any question, feel free to ask us any question or do any follow-up, and we can give you the customized demo.
Stop sharing a second. Okay. Just to wrap up a second. Let's bring you back the view. So thank you, Rajiv. That was an excellent overview, great demonstrations to show everyone how everything comes together. And in summary, again, as we've spoken about, we've helped many different clients to address their needs, whether companies such as Credit Agricole with their instant payment needs, a global trading platform for Société Générale, where they're providing instant replication across their 4 main data centers from Paris to US in terms of London, New York, and Hong Kong, to Avanza Bank that completely disrupted the Swedish banking market by providing a complete branchless environment, completely digital, and they became the #1 banking brokerage firm in Sweden. So we've done a lot of really interesting work across many clients. American Airlines has many production applications that they've deployed with us very significantly. So hopefully you've learned some new things today that may be of value to you. And in terms of moving forward, if you have interest, we're happy to do a technical review regarding your digital initiatives. We're also looking at having an enterprise architecture discussion to further review what you're currently doing and how we can help you. Obviously, the demonstration that we shared today was a high-level overview. We're happy to do a more tailored environment. And many of our clients then want to see how this applies to them specifically. And we are happy to go through a technical assessment document, define a hands-on workshop, and really validate your digital requirements. So we'd like to thank all of you in terms of your time today, and we look forward to following up with any questions you may have. So this concludes our session today. Thanks again for your participation.